ever since I was a kid, I've been super passionate about biotech. And when I first came to TKS, like Nadeem said, I started researching MRIs. And what I wanted to do was I wanted to learn about them at the fundamental level. So I wanted to learn the physics that underlies MRIs, how it actually works. Now, it took me a while to actually understand what was going on. And eventually, I became somewhat okay with the topic. But it came to a point where I couldn't really think of what to do next. I kind of understood what was going on, but I didn't really have any ideas of what to do with that. And I thought that, maybe there's a way I can connect my knowledge in MRIs with my knowledge in some other field that I'm researching. So I found a bridge between MRIs and cell biology. And so I came up with an interesting idea. I thought that, maybe instead of detecting the hydrogen atoms in water molecules, which is what standard MRIs do, we could detect other magnetic resonance sensitive nuclei in cells. And the ones I thought that were the most interesting were potassium and phosphorus, because that would give us a lot of good, interesting signatures on the metabolic processes happening within inside cells. And this would let doctors and radiologists diagnose diseases at the cellular level. So this could happen years before a disease even shows up in the patient. And so immediately, my mind took off, and I wanted to work with this. So one issue with this is that these type of nuclei are very insensitive. So there had to be a way for me to improve the sensitivity of that. So I developed a few techniques that I called focused ionic magnetic resonance, or FIMR for short, to improve the sensitivity of these. And to make this idea a reality, I founded the company Synex Medical. After doing that, I reached out to two companies. One was ANSYS, which is a simulation company, and the other Mount Sinai Hospital. Now, I can't just go ahead and build my own MRI. It's going to be a little tough. So I started, my first idea was to start simulating it on a computer. So ANSYS graciously put me in their startup program, and I got some software to start working with this. I also was given some access to some very powerful computers at Mount Sinai Hospital just across the street here, where I started working with the software. And while I was there, I started to realize I may have gone into this a bit fast. I should probably take a step back and just look at what I'm doing. So I took a step back, and I looked at the whole field of magnetic resonance as a whole. And I looked at the two main applications of it. One was imaging, which is what I was already working in, and the other was spectroscopy, which is another technique that mostly chemists use in labs to, instead of taking images of samples, instead they detect all the different molecules within a sample. And it's the same technology, just used in different ways. And I found something really interesting in spectroscopy. And that is that the area under each signal that you get from the molecule, so each peak you see in the spectrum, that area is proportional to the concentration of that molecule in the sample. And so this immediately blew my mind, because we could detect the concentration of something using a non-invasive technique like magnetic resonance. And I wasn't seeing many applications, so I thought, maybe I can think of something myself. And I thought, what if we could do this with blood? What if we could take a spectrum of blood and determine the concentration of all the different metabolites or molecules in blood without having to interact with it? And remember, this would be completely non-invasive, so you could do this inside someone's body without having to take the blood out of their body, meaning no needles, no finger pricks. And this would let us detect a bunch of things that we see in the spectrum, like the ones you see here. And the one here that gets me most excited is glucose, because that means no more finger pricking for diabetics. So after realizing this and the massive potential of this, I thought, there's two ways I can go. I can keep working with MRIs, or I can make a pivot and do this. And after a long time of thinking about it to myself and talking with a bunch of experts about this, I realized that the best way to go would be to pursue this blood testing idea. So I wanted to start working on it right away. And I reached out to a bunch of people and ordered a bunch of components so I could just build myself my own magnetic resonance system, an NMR spectrometer. And I built one in my room. Now, it was a little sketchy. There were a few things I had to just find around and put together. But I was able to get a signal. Now, if you compare that signal with what I should have gotten, this is a water spectrum, it doesn't look that great. But you still see a signal, which is not bad. The only issue is that the resolution is 5 orders of magnitude worse. So I wouldn't be able to detect any molecules in that if I had any. meaning this would never work on blood. So I thought to myself, there's got to be a better way to do this. And I realized that complex problems like this just can't be oversimplified. I can't just put it together and hope that it'll work and detect super sensitive or tiny molecules. And what I did instead was I went to one of the most prestigious labs in Canada that has these NMR spectrometers at U of T, and I started working with their instruments. So I ran a bunch of tests on blood samples to try to prove out this technique, and I also started working on the algorithm in which I would take these signals from magnetic resonance, from these magnetic resonance spectra, and determine the concentrations of all those metabolites. And what I did was, using that algorithm, I actually wrote a research paper at my school to determine the concentrations of ethanol in alcoholic beverages. I wasn't actually allowed to use blood on my school's NMR system, so I had to do this instead. And I also started working a lot on the hardware side of this. So I thought, what's the best way to actually turn this technology into a device that someone can use? And I found that one of the most practical ways to do this was actually in the shape of a ring. So so this would essentially be an entire magnetic resonance system in the shape of a ring that someone would wear constantly, and it would constantly run these non-invasive blood testing scans. So a user could track all these metabolites throughout their day. Now, where I'm at now is getting a final ring is going to be a bit of a challenge at first. So my plan is to get a slightly larger device that has basically all the same aspects as a final ring, just a bit larger so that I can start working with that. And I've actually ordered all the components for that, and it should be fully functional in about 8 weeks. So thanks a lot.